Proxima Centauri sounds close. It's called our nearest star, our neighbor, almost comforting. But that word is a lie your brain tells itself, because Proxima Centauri is not close in any human sense. It's close only on a cosmic map, where distances are so absurd that near loses all meaning. And once you translate that distance into time, you realize something uncomfortable. Reaching Proxima Centauri isn't just hard, it breaks the way we think about travel entirely. Proxima Centauri, close enough to dream, far enough to kill the dream. Proxima Centauri sits about 4.24 light-years away. That number sounds small until you remember what a light-year actually is. A light-year is not time, it's distance. It's how far light travels in 1 year, and light is the fastest thing in the universe. So when we say 4.24 light-years, we're saying even light needs more than 4 years to get there. Nothing we've ever built comes close to that speed. The fastest thing we've ever made. Right now, the fastest human-made object leaving the solar system is Voyager 1. It's moving at about 17 kilometers per second. That sounds fast. It is fast by everyday standards, but at that speed, reaching Proxima Centauri would take roughly 76,000 years. That's longer than all of recorded human history times 10. Civilizations rise and fall in that time. Languages disappear. Species vanish. A probe launched today would arrive at Proxima Centauri long after humanity itself may be gone. The first wall, chemical rockets hit a brick limit. So why don't we just go faster? Because chemical rockets, the kind that lift us off Earth, are already near their absolute physical limit. To reach even 1% the speed of light, a chemical rocket would need an impossible amount of fuel. Not a lot, an amount so large it becomes meaningless, more mass than entire planets. This isn't an engineering problem, it's a physics problem. Chemical propulsion simply does not scale to interstellar travel. That door is closed. Electric and nuclear engines, faster but still hopeless. What about ion engines, plasma engines, nuclear propulsion? They're incredible technologies. They can make missions inside the solar system faster and more efficient, but even with the most optimistic designs, they still measure travel times to Proxima Centauri in thousands of years. Better than 76,000, still completely useless for exploration within any human time frame. So Proxima Centauri forces an uncomfortable realization. If we want to reach another star, we need a different category of movement entirely. The speed that changes everything, a fraction of light. To reach Proxima Centauri within a human lifetime, a spacecraft must travel at a significant fraction of the speed of light. Roughly 10% of light speed, about 40 years. 20% of light speed, about 20 years. That sounds almost reasonable, until physics speaks up again. Why you can't just go faster. Anything with mass resists acceleration. As you approach light speed, your energy requirements explode. To reach light speed, you'd need infinite energy. Not a lot, not future tech, infinite. Which means light speed is not just difficult, it's forbidden. So the question becomes, how close can we get without breaking physics? The radical idea, don't carry fuel. This is where everything changes. What if the spacecraft doesn't carry fuel at all? What if Earth does the pushing? Instead of engines, you use light itself. Photons carry momentum. If you reflect enough of them off a surface, they push. This is the idea behind light sails. An ultra-thin sail, a tiny spacecraft, and a powerful beam of light pushing it forward. No fuel on board, no tanks, no propellant mass, just acceleration. Laser sails, turning Earth into the engine. Solar sails alone are too weak, but lasers change the equation. A powerful array of lasers based in space could focus energy onto a sail and accelerate it to 15 to 20% of light speed in minutes. At that speed, Proxima Centauri becomes reachable in about 20 to 30 years. For the first time, the numbers stop sounding insane. This is the core idea behind humanity's most serious interstellar concept so far. The catch: everything becomes fragile, but nothing is free. At those speeds, dust becomes bullets, radiation becomes lethal, navigation becomes razor-thin, braking becomes nearly impossible. These spacecraft cannot slow down, they don't arrive, they flash through. A flyby at a significant fraction of light speed lasts hours or minutes. You get one pass, one chance, no second orbit, no landing, just data screaming past at relativistic speed. Why humans aren't going? Now imagine scaling this up. Not a gram-scale probe, but humans. Life support, shielding, radiation protection, food, redundancy, psychology, decades in deep space. The mass explodes. And once mass explodes, the entire laser sail idea collapses. Interstellar travel with humans is not just harder than robotic missions. It is a different problem entirely, one we don't even know how to frame yet. The quiet truth. Proxima Centauri isn't impossible because we lack courage, intelligence, or ambition. It's impossible because space is bigger than human intuition, and the universe doesn't care how badly we want to cross it. If humanity could fund only one interstellar strategy, which should it be? A. Tiny laser-pushed probes reaching other stars this century. B. Waiting centuries for technology that could carry humans instead. Comment A or B and explain your choice. And if you want to explore what humanity might become beyond Earth, beyond tomorrow, beyond 2200, subscribe.